Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready. Grab a notebook, a pencil, or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today, for my pre-calculus students, there are some Algebra 2 skills that you need to be familiar with and you need to recall from last year. Otherwise, you will not be successful in pre-calculus. This is not comprehensive, so there are other skills that I may cover at a later time in another video. But for a lot of you doing the first unit, wrapping that up, which is mostly a review unit of Algebra 2 skills, I want to check in with you and make sure that you understand what you're doing here. So go ahead and give yourself about, let's say 12 minutes. Try to work these out for yourself. I'm not going to give you any specific hints or anything beforehand. I want you to recall as much as you can. Then when you're ready, you can unpause the video and see how we did it here. Okay. So first things first, let's get some spice. That's probably enough space. And that's definitely enough space. Okay, number 1 wants us to rationalize the denominator. So you might remember that rationalize the denominator means we don't want any radicals in the denominator. So a student of mine made a decent recommendation, a decent guess at what should be done. And that was to multiply the top and bottom by square root of 3. The issue with this, even though it is a great guess, the issue with this is that we don't have a single term in the denominator. We have 2 terms in the denominator. So we would be multiplying both of these by the square root of 3, and while it would totally fix this situation, we would just have negative 4 times 3, it will kind of ruin this situation because now we'll have a radical on that term. So even though it was a good guess, and that is something that would have worked if we had an expression like just 2 rad 6 over 5 rad 3 or something, this would totally fix the situation. There's not just a single term down there, we have more than one term in the denominator. So we have to take advantage of the conjugate. The conjugate of a radical expression is kind of like the evil twin, sort of like the opposite twin. So if we have 4 minus 4 square root of 3, it's kind of what this is, right? Then the conjugate would be 4 plus 4 square root of 3. Okay? And the reason why we want to multiply that, I'll show you why. I'm going to rewrite the denominator as 4 minus 4 root 3. I hope you're okay with that. This is the same as a minus b. So I want to try to multiply this by a plus b. What would I have to multiply by? I would have to multiply by 4 plus 4 root 3. And that's going to create a nice difference of squares in the denominator. Things aren't going to work out that nicely in the numerator, to be perfectly honest, but in the denominator, we're going to simply get a squared minus b squared, which is just going to be 4 squared, or 16, minus, here's the beauty, b squared cancels the square root. And if you work that out, you get 48. Now in the numerator, this is also good practice for your FOIL skills. You need to know how to do FOIL. First, outer, inner, last, or whatever you want to call this binomial multiplication method. You can use a box method or some other kind of multiplication table. Doesn't really matter to me. But at the end of the day, you should have 8 root 6. We don't have a lot of common terms here, unfortunately. 8 root 18, which I'll fix in a moment. 4 root 3, and 4 times 3, which is just 12. So if we simplify all this a little bit, we can divide a 4 out of everything, and we can also change the square root of 18 to 3 root 2. So this is 24 root 2, 4 root 3, 12. So the final step is to just take out some common factor. I guess I'll divide a negative 4 from the top and bottom, and then this will be negative 2 rad 6 minus 6 rad 2 minus root 3 minus 3 all over 8. and that is the simplified form. Because these terms are all different radicals, they are not compatible. This is kind of like if we had negative 2x minus 6y minus z, we would not be able to combine any of those. They're not common terms. Okay. All right, let's move on to the second type, a complex fraction. I'm not predicting that you're going to have much complex fractional work in pre-calculus or calculus, but knowing how to do these tricks is really useful for simplifying expressions, and it makes you practice your algebra, which is the goal here. It's pre-calculus, but we're recapping on your algebra skills. Now, some people will try to get a common denominator on the top, and get a common denominator on the bottom, and then flip some fractions and all that good stuff. But really what we should do is we should multiply the top and bottom by the LCD. So you look at all of the denominators that exist, and you find their least common multiple. So for x squared and x, those are the only denominators, our LCD is x squared. Meaning, if I multiply the entire top half by x squared, and the entire bottom half by x squared, this will cancel very easily. Do you see how? If I distribute x squared in the top, what is this going to give me? Let's move the LCD commentary to the on the numerator. This is going to give me simply 3 because the x squareds are going to cancel. And then for the next term, we're going to have plus 6x. In the denominator, we can distribute x squared, and it's going to cancel the x squared to leave us with a 2, and then it's going to cancel the x with an additional x, so that we have this here. Okay, so we can't really factor this too much, but if you wanted to factor it, we can leave it as 2x plus 1, or 1 plus 2x if you wanted to leave it in that order. And then on the bottom, if I take out like negative 2, this would be 2x minus 1. So they don't quite cancel. It would be really nice if they cancel. If you wanted to leave it like this, I'd be okay with that. This is also acceptable. Okay, pretty easy that one, yeah? Good. We didn't need much space for it. It's a much shorter process to just bust the entire fraction set on the top and bust the entire fraction set on the bottom at the same time. Then you have no more fractions. Even though I know you love fractions. And the third, this is an equation that we need to solve. Now, when it comes to equations, we have to be careful because any kind of rational expression, which is basically a fraction with x in the denominator cannot equal 0. So anything that would make the denominators here 0 would be a problem. First, let's factorize this expression because we might get some other additional denominators. Hint, hint, we won't, but if we factor this, a really good clue for what you should try as your factors if you were like completely unsure of how this factorizes, just look at these denominators and maybe get some inspiration from one of them or two of them and try them and say, oh yeah, that does work. So pretty straightforward. That means that x cannot equal 4, otherwise this fraction will be ruined, and x cannot equal 2, otherwise this fraction will be ruined. So what we're going to do is we're going to multiply x minus 2 on x minus 2. We're going to multiply x minus 4 on x minus 4. And that will leave us x minus 2 plus, always use parentheses here, x minus 4 times x. And this just equals 2 because now that everyone has the same denominator, we can really just cancel out the denominators. We already took into account what values would make the denominators 0, so we can just completely ignore these. They're all shared denominators. And we can move on as follows. We have x minus 2 plus x squared minus 4x equals 2. And this is a quadratic equation, which simplifies pretty easily and is factorable. X minus 4, x plus 1. Now, this would suggest that x equals 4, and this would suggest that x equals negative 1, because we're using this beautiful zero product property, which says if you multiply multiple things, like more than one number, and you get a product, if that product is 0, then one of the objects had to be 0. That's basically what it says. However, we have to reject the answer x equals 4, because if you go back to our restricted values, our excluded values have 4 on the list. So the only solution here is -1. And you can totally check if you really wanted to. 1 over -1 minus 4 plus x, which is -1 over x minus 2, should be equal to 2 over -1 squared minus, 6 times -1 plus 8. Let's see if that even adds up. 1 over -5 minus 1 over -3. Well, this is kind of weird. -1/5 plus 1 over 3. That looks a little bit better. This would make -3 plus 5 over 15, or 2 over 15. That looks promising. And over here we get 2 over 1 plus 6 plus 8. Hey, what do you know? That's 2 over 15. So our answer is confirmed, our solution confirmed, and we are done. As I said, there are other skills you will need to know. Solving a different type of equation and also working with exponents is going to be a fundamental part of your early pre-calc requisite. So you'll probably see another video from me with regards to some more pre-calc Unit 1 review. But that's enough blab out of me for now. I'll see you guys next time.